first of all, on the 30, 60, 90 one, you don't actually know it's a 30, 60, 90 because I did not put those numbers on there. So this should be 30 degrees here. And I should have given you that. You cannot assume that angle measures are 30 and 60. Okay. All right. So how do we know that this one's a 45, 45, 90? Okay, the two angles are congruent, which would then mean the sides are congruent and also mean these have to be 45 degrees. Okay, so Kendall, can you tell me what to do?
So the hypotenuse is 7. Which would make it, like when you put the radical 2.
Yeah, that's the radical 2 side. Okay, and then these are the 1 sides. So what do you do? We're trying to go from the hypotenuse back to the legs. So on these problems, you're either multiplying by root 2 or you're dividing by root 2, which is it. Yeah, you're trying to get a smaller number, right? When you're trying to get a smaller number, you divide by root 2. Okay, Braden, what do you do then? Yep, we're rationalizing. We're trying to get rid of that radical on the bottom. So root 2 over root 2. And then that's 7 root 2 over 2. Are there any other ways you can write that answer? Yes, it's actually okay to put 3.5 root 2. You never want to round, but because 7/2 is 3.5, it's perfectly fine to call that 3.5 root 2. Sorry, that looks terrible. 3.5 root 2. And obviously x and y are the same value, so y and x are both 3.5 root 2. Okay, and then for the 30, 60, 90. So Sarah, tell me where the numbers go, the 1 and the 2 and the root 3. I gave you the triangle up here at the top. Do you see that? 2 is which side? Yeah, it's the hypotenuse, right? The hypotenuse is 2. So that's where our 2 goes. Where's the 1? The y. The short leg across from the 30 is our 1. And then the other long leg is our root 3 side. Okay, Michael, can you tell me how to find a short leg? By if this is the root 3 side, when you're going between the short leg and the long leg, you're either multiplying by root 3 or dividing by root 3. So if you're trying to get a smaller number, would you divide or multiply by root 3? You're dividing. Okay, so we're going to take 5 root 6, divide by root 3. Jaron, where would you go from there? And then root 18 breaks down. Then what? Really? Okay, and then what? Okay, good. Did anybody else get this in like 2 seconds and thought, why did he not do this? Kara, what did you do? 5√2, just divide the radicals. Okay, remember the numbers in the front can divide and the radicals can divide. So did Jaron get there? Yeah, he got there. It's just not the quickest way, right? If you're able to divide the radicals, then do that. And your y value would be 5√2. Okay, so this is 5√2. Sometimes it's helpful to put it on the picture so you can make sure that you've got all the numbers there. All right, and then Rylan, tell me how to find the hypotenuse. Okay, you could do the Pythagorean theorem, but that's not necessary with special right triangles because we know the relationship between the sides. So could you do that? Yes, but it's going to take time. Okay, guys, you've got to pay attention to the time on this quiz because there's so many problems that you can do a quick way or a long way, and you want to make sure you're paying attention doing the quick way. How do you turn 5√2 into the hypotenuse? If it's a 1-to-2 ratio, what do? Multiply it by 2. Okay, Rylan, what is that when you multiply that by 2? Okay, there's no radical on this number. That means the radical 2 doesn't change. If it was like 2√3 or something, then you would multiply the √3 and the √2. But because there's no radical there, you're just multiplying the number on the outside and making it 10√2. This is really the same thing as 5√2 plus 5√2, right? You're doubling it, which is 10√2. All right. Well, that was painful. Okay, let's go ahead and go back and finish notes on trig stuff. So let's see. We will go over homework, but I don't want to do that yet. Okay, so remember our mnemonic device is SOHCAHTOA. Again, this was lesson 8.3 from March 31st. So Jake and Jaron, it's shocking how I can see your faces now. And when you're at home, I can never see your faces. Huh? I know. That's how it should be. Cover your nose, please.
I think my nose already works now, and I'm
Okay.
taking notes in my first time on the board. So should I just say,
I'm going to airdrop it. Do you have your airdrop on? Okay, calculator. So remember that sine, cosine, tangent are just ratios of sides. In any right triangle, when you have fixed acute angle measures, the ratio of like the opposite to the hypotenuse will always be the same, or the opposite to the adjacent will always be the same. Okay. Your calculator has been programmed to be able to figure out those ratios. Now, you need to make sure that you're in degree mode. So on a graphing calculator, again, it's a mode button that's up by the yellow button in the upper left corner. And you need to go to where it says, I think it's like the fourth entry down. It says radian versus degree. You want to make sure degree is darkened. Is there anybody who's using a scientific calculator that didn't figure out how to reset it? So there's in your on your screen there, it should either have a setting that says like DEG, or maybe it has a D. You don't want it to be R or radian, you want it to be degrees. If you need me to look at your calculator, bring it over here and I'll see what I can do. It's usually some kind of mode setting. So sometimes there's a degree button that you just push until you get in the right setting. Sometimes there's a DRG button, degrees, radian, gradient. Sometimes there's a DRG or a DRG. Okay, go ahead and just type in the calculator, sine 30, tangent 30, cosine 30. Just go ahead and fill out that table. You're rounding to 4 decimal places. Yeah, I don't know why it says stat there. I don't think it matters though. Stat might be the number of decimal. Let's see. You have a mode button sometimes are setting. And I don't know why that. Oh, it's conversion. Yeah. So if you just hit this button, it toggles it back and forth. So if you never change it, it'll stay on degrees. But if you when you start a problem, you just want to kind of make sure it's on degrees.
Okay.
I don't know what the stat button is.
Okay.
You also need to make sure you can see enough digits. Okay. You're going to want to be on, you're on degrees, but I think you need to be on class for it to do what you need to do. Yeah, so let's see if I get tangent 30. Yeah.
So it's right?
Yep.
Okay. Okay. I just
You're set? Okay.
Yeah. I just enter it, but
Yes. So some of you have a calculator that will do radicals. And so when you're doing trig stuff, you need to get it into classic. So is it like a mode button? What's the button?
mode and then
Yeah, the mode button, and then like the fourth selection down, you want to scroll over to where it says classic rather than math print.
I'm gonna have to do this every time.
If when you start trigonometry problems, you need to make sure you're in degree mode and that you're in, if you're using that kind of calculator, classic mode.
Okay.
But if you never change it, it won't change unless
Okay.
like if your calculator dies, like if you have a graphic calculator, the calculator dies, it'll reset. You got to redo it again. But just kind of always check it and make sure that everything looks good. Peter, do you have a question?
Yeah, I have
Bring here.
What's in the mode section?
Okay. Let's see if we want to do 3. Okay, so if you do shift mode where it says setup here,
Okay.
and then press the number 3, it puts it in degree mode, and you'll be able to see that because there's a D up here.
And where's the do?
It there's different ways of measuring angles. So one of them is degrees, and then there's other ways as well. Okay. Once you get into pre-calculus where you're doing more trigonometry, you'll do measuring angle measures of what are called radians. We're going to do everything in degrees. So everything you do in geometry is going to be set in degrees. Radians is a different way of measuring angles, just like you have inches and centimeters, like American and metric. It's just a different way of measuring. Okay, so sine 30, 1/2. That's exactly 0.5, so you don't need to do any rounding on that one. 0.5, and if I was going 4 decimal places, I should technically do 0.5000. Cosine 30, what does that round to, Jake? 660. Okay. Tangent 30. What?
You said I have like 1/2, and it's like radical 3/2.
That's SD. The SD thing?
It's also maybe your mode. You know how I just said using classic instead of math print? It sounds like it's trying to put it into radicals. It's √3/2 is what it's trying to say. You want to go to mode, go down to where it says classic, hit enter. And then if you do tangent 30, it'll give you decimals.
Oh, okay.
You need to toggle back and forth between classic and math print if you want to be in decimals versus radicals.
Okay, classic.
Yeah.
And then enter.
Yeah, and then hit tangent 30. Oh, put out it. Yeah, that's not one. So if you go to the second clip, it'll give you back. So, okay. So then tangent 30 will give you decimals.
Wait, what mode is it?
So yours, yeah, you want to be in degree mode.
Oh.
So if you do tangent 30, and you're in the other thing, you need to be in, let's see, oh, scroll down. Classic.
Oh, okay.
Did you see where there's a little A? Yeah. That means you can scroll down. So if you want to be in decimals, it has to be in classic modes. And then if you do tangent 30, you do decimals.
Okay.
I have no idea. I was just using these buttons that
So you go to mode button.
Oh,
Okay, and you probably want to be up there in classic to get decimals. Jake, sit down. and then you want to be in radians. So when it's darkened, that means that's what's selected.
Okay.
So if you never change it, it's going to stay that on that setting, unless your battery dies or you let somebody else borrow it. Yeah. Okay. Are you getting the decimals for the other ones?
Yeah, I don't have any first one too.
Well, that was probably
I got
before.
0.5.
That was the. Yeah, it's not. I mean, because it says 4 decimal places. You don't really have to do that. You can leave it 0.5. That'd be fine. Because it says round it where necessary. You don't even have to round that one. So it's okay to put 0.5. I thought you were saying you were literally getting 1/2. Okay, you should be getting decimals for those. Holy cow. Okay, do you remember that we talked about how when you're looking at complementary angles, okay, so we were doing like, if you have 50 degrees, sine of 50 is the same as the cosine of 40. So sine of 30 would be the same as the cosine of 60. So that should also be 0.5. And then cosine 30 should be the same as the sine of 60, 0.8660. Now for tangent 60, how were these two numbers related to each other? Look at the table. They're flipped. They're reciprocals. So you can go ahead and just type in tangent 60. That's perfectly fine. Okay, but you also, if you had typed in tangent 30 before, there's a button on my calculator. It's right there. It says x to the -1. Okay, and that means reciprocal. So if I had the tangent of 30 in already, and I did take the reciprocal of that, oops, sorry, I hit the wrong thing. Take the reciprocal of that. I don't mean second, I just mean first button. It'll also give you the right tangent value. Okay, 1.7, what is it, 4 decimal places? 7321. Okay, now these are the problems that you probably had some issues with on the homework. There are a couple of those like this. So we're supposed to be finding the values of variables. The z is the easy one on this problem. How do you find z? Okay, that will work. But you also know that these two angles have to add to how much? 90. So it's a little quicker to just do 90 minus 36. Again, not wrong to do subtract from 180. It'll just save you time to just do 90 minus that. So what is that, 54 degrees? Okay, now, when you go to do the x or y value, I'm going to go ahead and use the value that was given there. So I'm not going to use the 54. I'm going to use the 36 that was given. My little degree symbol got down there for some reason, so 36 degrees. Okay, to find x, we need x in the equation, and we need to use the number side length that was given. Now, this is how you set these up. So remember, it goes so is sine is opposite of hypotenuse, cosine is adjacent over hypotenuse, tangent's opposite over adjacent. Let's go ahead and label the sides in relation to the 36 degrees. What side is 8? That's the hypotenuse. Hypotenuse is always along the side across from the right angle. Okay, and then the x, is that opposite or adjacent leg? That is the opposite leg. Okay, Ryan, sine, cosine, or tangent? Oops, didn't put an equal there. Sine, cosine, or tangent? Okay, tell me what the equation is. Sine of what? The thing that follows sine, cosine, tangent is always an angle. So sine of what? We're using the 36-degree angle because we use the opposite hypotenuse relation of 36. Okay, so it'd be a sine of 36 is equal to, what's the opposite length? And then the hypotenuse is 8. Okay, the reason we need to use sine is because we're using opposite and hypotenuse, and sine is the one that uses opposite and hypotenuse. Okay, when you start the problem, I would recommend that you go ahead and write this out so it's right in front of you. And then I would recommend that you label the sides so that you've got it directly in front of you and you can tell what's going on. Okay, now this is an equation. Sine of 36 is just a number. How do you solve for x? How do you x alone? The x by itself. Multiply by 8, right? And then that's what we're typing in the calculator. Before you touch your calculator, I want you to solve for the variable, and then you can show me what you're typing in the calculator. Okay, I need to see the original equation. I need to see solving for the x or y or whatever, and then I need to see what you're typing in the calculator in your answer. 8 sine of 36. You probably don't have to put the times button if you're using a graphing calculator, but you might have to on your others. But this is why I want you to have a calculator you're comfortable with, because all calculators work a little bit differently. So this is why I want you to be using the same calculator all the time. Okay, so x is approximately, and I think I said the nearest 10th, so that would be about 4.7. By multiplying 8 by sine of 36. Yeah, and if you write it like sine 36 times 8, make sure that you do that, because you don't want to think that you're doing 36 times 8 and then taking the sine. It's kind of like standard notation to write the number in front of the sine, cosine, or tangent. Okay, and then in relation to, here's our, let me switch colors here. In relation to the 36-degree angle, the y, we're going to use the 36. I'm going to relabel these. Okay, we're still going to use the 36 and the 8 because those are the numbers that we need, but we're going to find y this time. So let's label the sides. Austin, tell me where the opposite adjacent hypotenuse are in relation to 36. In this triangle, what are the opposite adjacent hypotenuse? Okay, so that didn't change, right? What's the y value? The y side. Is that opposite or adjacent? That's adjacent. Okay, and again, we had the opposite there before, but we don't need it this time, so I'm just going to get rid of it because you just want to kind of pretend like the only thing you care about are the one variable and then the numbers that you got there. Okay, so which way, what? We're solving for a y, it's only one left. Grace. Okay, on this one, they actually didn't change. I just changed colors because I was finding a new variable. When you start the problem, if you start with 36 degrees, it'll stay opposite like that, adjacent like that, hypotenuse, and it will never change. If you jumped up here to the 54-degree angle, now those guys would switch around. But you don't even have to use the 54. So I would recommend you just go ahead and stick with the number you were given in the problem. The 36 was provided, right? So just use the 36 and 8 that were given, and then you need an equation with 8, 36, and y. It'd be y, right? But yes, you could. Lily, tell me, is that sine, cosine, or tangent? Yeah, that's cosine of, give me the whole equation. Equals over hypotenuse, y, right? Okay, and then again, we're multiplying by 8 to get rid of that denominator. And that'll give us y is approximately, I'm rounding, that's why I'm writing it like that. Y cosine, sorry, 8 cosine 36. Rounded to the nearest 10th would be what? 6.5. Now, you don't have to do the little approximately symbol. I'm doing that to indicate that I rounded. I'm not going to count it wrong if you were at y equals or x equals, okay? But you'll just see me do that because that means I rounded. Okay, so to find y, we're looking at the angle with the adjacent and the hypotenuse. Adjacent hypotenuse is cosine, right? Since you're using adjacent hypotenuse, that means you're doing cosine. So if you label the sides opposite, hypotenuse, and adjacent, then you'll be able to look at it and say, in relation to this angle, is it going to be sine, cosine, or tangent for the two numbers I'm using? So for that previous one, we were using the angle measure and the opposite in the hypotenuse. So that's why we did sine, because opposite of hypotenuse. Peter. Yeah, it's the leg that's not the hypotenuse. Yeah, the one that's next to it that's not the hypotenuse. Yep, opposite adjacent are always legs. Okay, let's go ahead and do one more of these so we get comfortable. What's the fast way to find z? What's the fast way to find z? Izzy, tell me how to get z. -90 - 38. And again, it's not wrong to subtract from 180. It'll just take extra time that's not necessary. So since those two have to be complementary, that'll make it, what, 52 degrees. All right, now let's go ahead and just use the angle that was given in the problem. Okay, let's use the 38 degrees and let's label the sides opposite, adjacent, hypotenuse based on that angle measure. Okay, again, z is 52. Don't even worry about 52. Just use the 38. All right, Blair, tell me where the hypotenuse is. Okay, where are the opposite and adjacent? Where are the opposite and adjacent? And again, it's opposite because it's across the triangle. It's a leg, okay? And that means this one is the adjacent because it's the leg that's next to 38 degrees. And again, the hypotenuse is the hypotenuse, it never changes. But adjacent will be the leg that's making the angle, but it's not a hypotenuse. Okay, so first thing I'd recommend you do is write down SOHCAHTOA. So you got that in front of you. I'm actually going to give you that on the quiz. I'm also going to give you the little reference triangles. You know how on that problem that we just did, and I drew the little 45, 45, 90, 30, 69. I'm going to give you that as well. Because I know we've had a lot of interruptions here and I want to help you out a little bit. Okay, so Blair, I'm sorry, not Blair, Diamond, why don't you tell me to find, let's do X, to find X, what numbers do you use? Uh-huh. X, and then, well, if you use X and Y, you'll have two variables, right? Okay, so is that going to be sine, cosine, or tangent? So then you look at, yeah, it's tangent, right? It's opposite over adjacent. So it'll be tangent because tangent uses opposite or adjacent. Okay, Blood, can you give me the tangent equation? Tangent. Okay, tangent of what? What comes after tangent? The thing that follows sine, cosine, tangent is always an angle. So it'll be tangent of, well, if we're using opposite and adjacent, that's in relation to 38 degrees. So it'll be 38 degrees. Okay. I intentionally did not write the 52 there because I don't want to confuse you. We know this is 52, but let's just use the angle that was given. Okay. Tangent 38 is opposite 14 over adjacent X. Now, this one's a little harder because the variable's in the denominator, but you're still trying to get the equation solved for X. One option that you might feel good about is just put this over 1 and turn it into proportion. Okay, and then when you cross multiply, it'll get rid of the variable in the denominator. So that's one option. That would look like X tangent 38 equals 14. How do you get X alone? Divide both sides by tangent 38. So that's what you're typing in the calculator then. Okay, so grab your calculator and make sure you know how to do, sometimes division on the calculator is a little weird. If you have certain calculators, it kind of understands what you mean a little better than others. Okay, type that in the calculator, make sure you're using it correctly, 17.9. X is approximately 17.9 to the nearest 10. That's what we were solving for. So X is, that's what we're typing in the calculator is X equals 14 divided by tangent 38. Now, I'll show you a different way of solving that also. So now let's go ahead and find Y. So we're still going to use a 14, we're still going to use a 38, but now we want Y in our equation. Okay, so Grace, can you tell me, will that be sine, cosine, or tangent? Is it sine, cosine, or tangent? We're going to use 38, 14, and Y. So if we use tangent, we're going to have an X and no Y in there because tangent would go, the tangent of 38 is the opposite over the adjacent. Okay, that's what we just did, that found X, but that won't have Y in the equation. So to find Y, we're using the hypotenuse and the opposite. Which one uses hypotenuse and opposite? Okay, so it'll be sine of, Peter, tell me what the equation will be. The thing that comes after sine, cosine, tangent is always what? An angle. Okay, so sine, cosine, or tangent of an angle. So sine of 38 equals no, I don't want you to do that yet. I want you to write an equation. Don't touch your calculator yet. Sine of 38 equals, I want the equation. Sine is opposite of hypotenuse, so what's the ratio? Yeah, no, 14 over sine of 38 is opposite over hypotenuse. So it'll be 14 over, that's what we're trying to find, right? What's the variable? Y. Okay, now, the last time I told you, one option is to throw it over 1 and make it into proportion. Another option is to say, okay, we're trying to solve this equation for Y. How do you get the Y out of the denominator? This is just a different way of solving the same kind of equation. Multiply by Y on both sides. Okay, I'm going to rewrite this just so it doesn't look confusing. That's Y sine of 38 equals 14. Okay, how do you get Y alone? You divide it by sine of 38. So that's two different ways that you can do the solving when the variable is in the denominator. If you like this proportion way, then do that. Put it over 1 and cross multiply. If you would rather just think it's a variable on the bottom and want to get it out of the denominator, multiply and then divide. That's kind of your second option here. Okay. So what you're typing in the calculator, you should not be touching your calculator until the very, very end. I should be able to see on your paper what you're going to type in the calculator. Okay, so we're typing in the calculator 14 divided by sine 38. All at one time, and then round it to the nearest 10th. It'll be what? 22.7. Again, that's a length. 22.7. Now there's another way that you can do once you have the first answer. There's another way that you could finish the problem. If you know that, so you've done the first calculation and you figured out that X is about 17.9. What is another way that you can find the y value from those two numbers. Pythagorean theorem. So if you prefer to do the Pythagorean theorem, that's okay. It's not necessarily faster, it might be, but you have to do trigonometry at least one time, because when you don't have two legs, you can't do the Pythagorean theorem. So you're gonna have to find either x or y prior to doing the Pythagorean theorem. So this is another option. And that would be 17.9 squared. That says or. 17.9 squared plus 14 squared equals y squared. Okay, so Pythagorean theorem is fine. All right, let's go back to homework and check those problems. So here's number 29. Whoops, I'm in the wrong place. Hold on. 29. Now notice that every time I'm labeling opposite, hypotenuse, and adjacent so that it's right there and I don't have to think so hard. I would strongly recommend that you, whatever angle you're looking at, so see how here it says angle C, then from C, your opposite, adjacent, hypotenuse. Questions on 1 through 6? Yeah. How do we do with those? Oh, because it says like the sine of angle C. So if it says sine of C, that means from angle C's perspective, that's your opposite and that's your adjacent. If it said sine of A, then you would be looking at this and it would switch those guys around. But the problem said C, so that's how you know which angle to go to. Any other questions on 1 through 6? Okay, now 11 and 12 are the ones that we just did. So you probably didn't really know what you were doing on those, but 7 through 10, if you had not figured out how to get your calculator in the right mode, then you probably had trouble with that. But if you got any of those wrong, 7 through 10, you should right now type them in and just make sure it looks right. Because when you were doing it, you may not have had your calculator set up correctly. Okay, so for 11 and 12, let me put that back in there. So, okay, so when you look at number 11, you got an 18-degree angle, you have the 6, and you have the x. First thing we should do is go ahead and label those sides. So across from the 18 is 6, so that's your opposite. What's the x side? The hypotenuse. Okay, so we've got the 18 degrees, we've got the opposite, we've got the hypotenuse. So are we doing sine, cosine, or tangent? Sine, opposite, hypotenuse, okay? So the sine of 18 is the opposite divided by the hypotenuse. It's always sine, cosine, or tangent of an angle. Okay, it's always sine, cosine, or tangent of an angle. So the sine of 18 is 6 over x. That pink is like the original equation, okay? Now I'm doing it by solving for x by multiplying both sides by x. So then your next equation looks like x sine of 18 equals 6. If you have x sine of 18 equals 6, Kendall, how do you get x alone?
You multiply by your x's. If you had multiply the x to
Yes, after that, when you have x sine of 18 after you multiply it, how do you then get x alone?
do 6 over
Yes.
sine.
So we'll divide both sides by sine 18, and that's what you're typing in the calculator. Okay, type that into your calculator right now and see what you get. 6 divided by sine of 18. 19.42. On this one, I said 100. Okay, so 2 decimal places. And then for number 12, we've got 61, we've got x, and we've got 8. Okay, so 61, x, and 8. So that means we're using what? Sine, cosine, or tangent? We're using opposite and adjacent. So it'd be tangent. Okay. It's opposite over adjacent, so it'll be tangent. So it's because we're using the x is your opposite and 8 is your adjacent. Opposite and adjacent is tangent. So the tangent of 61 is x over 8. The ones for the variables on top is a little easier because you can just multiply by the variable and then, by the number, and then you're done. When the variable's on the bottom, it's a little bit more work. And again, when you type 8 tangent 61, you should get 14.43. Okay, any questions on the trig stuff? What are you getting? 6 divided by sine of 18. Are you doing sine? Okay, so again, you're starting out with this equation. Sine of 18 is 6 over x. Then I'm multiplying both sides by x to get the variable out of the bottom. And then you've got to divide the sine of 18 on both sides to make it cancel out. After we check, yeah, you can resubmit. Okay, guys, let's check the second page here. And then I'll have you resubmit homework if you had lots of issues. You can go ahead and resubmit it when we're done checking. So you do want to notice that while you could do trigonometry for some of these, like this one, you could do the cosine of 45 is 25 over x. I don't want you using trig whenever I'm asking you for radical answers, okay? If they've got 45, 30, or 60-degree angles in the problem, then you should not be using trigonometry, okay? If it's got 45, 30, or 60 in the triangle, then you should be doing special right triangles. Diamond. Okay, the hypotenuse is what you're given. So you're given the radical 2 side. I'm sorry, I said that wrong. The legs are what you're given. So you're just multiplying by root 2. to get to the hypotenuse. You're not dividing, you're multiplying. When you're trying to get a bigger number, you're multiplying. When you're trying to get a smaller number, you're dividing. Okay, when you're going from the legs to the hypotenuse is longer. So that means you need to multiply by root 2. So that one, there's not even actually any simplifying to do. You just multiply by root 2 and you're finished. Yeah, the legs are 50. And again, you can do the Pythagorean theorem, but it's going to eat up a bunch of time when you can just look at that and go, oh, it's 50 root 2. Questions on 1 through 8. Anything else? Okay, how about let's just look at the middle ones here, 9 through 14. Number 13 is really weird. Do you know why I'm saying it's weird? See where they've got the 30? Across from the 30 is supposed to be the short leg. It doesn't look like it, but that's what you have to assume. Okay, wherever the 30 is, across from it is the 1. So this is actually the short leg is 21 root 3. Okay, how about 9 through 14? Do you need to go through a couple of those? Michael? Okay, so this is the hypotenuse. This is the hypotenuse. This would be your short leg, and this is your long leg. So that means this is the 2, this is the 1, and this is the root 3. So when I'm going from the hypotenuse to the short leg, and again, you always go to the short leg first, no matter what you're given, you go to the short leg first. Since this is a 2-to-1 ratio, that means we're dividing by 2. So if I do 52 root 3 divided by 2, then you can just divide the 52 by 2. Let me switch this back. Oh my God. 52 root 3 divided by 2 is 26 root 3. Okay, the numbers in the front will divide. And then since the short leg is 26 root 3, I'm multiplying by square root of 3. So this is our 1. We're trying to go to the root 3 side, so we're multiplying by root 3. And then root 3 times root 3 is 3. So 26 times 3 will give you 78. Okay, take a look at 15 and 16 there also. I'll leave that up there. Which one? Okay. All right. If you need to resubmit, go ahead and resubmit that.